Artificial intelligence, the dawn of thinking machines. The universe is filled with wonders, from the vast expanse of space to the intricate workings of the human brain. For centuries we have gazed at the stars and pondered our place in the cosmos. We have also marveled at the power of the human mind, its ability to learn, adapt, and create. Now, in the 21st century, we stand on the cusp of a new era, one in which we create machines that can mimic and even surpass our own cognitive abilities. This is the age of artificial intelligence. Artificial intelligence in its simplest form is the ability of a computer or machine to perform tasks that typically require human intelligence. These tasks include understanding and responding to language, recognizing patterns, solving problems, and even making decisions. AI is not about replicating the human brain, rather it is about creating systems that can exhibit intelligent behavior, regardless of whether they mimic the processes of the human mind. From self-driving cars that navigate our streets to virtual assistants that answer our questions, AI is rapidly becoming an integral part of our lives. The field of AI is vast and constantly evolving, encompassing a wide range of technologies and approaches. However, at its core, AI is about creating machines that can think for themselves, learn from their experiences, and adapt to new situations. Machine learning. Learning from data. One of the most powerful and widely used subsets of AI is machine learning. Machine learning is a type of AI that allows computers to learn without being explicitly programmed. Instead of relying on predefined rules, machine learning algorithms learn from data, identifying patterns and making predictions based on the information they are fed. Imagine teaching a child to ride a bike. You wouldn't give them a step-by-step manual on how to balance, pedal, and steer. Instead, you would let them experiment, fall, and learn from their mistakes. Machine learning works in a similar way. By providing a machine learning algorithm with a large data set, we can train it to perform a specific task, such as recognizing images, translating languages, or predicting customer behavior. The beauty of machine learning lies in its ability to adapt and improve over time. As the algorithm is exposed to more data, it refines its model, becoming more accurate and efficient at its designated task. This ability to learn from data is what makes machine learning so powerful and is driving its widespread adoption across industries. The learning machine. How machine learning differs from traditional programming. To truly grasp the revolutionary nature of machine learning, it's crucial to understand how it differs from traditional programming. In traditional programming, we explicitly tell the computer what to do. We write code that defines every step the computer must take to solve a problem. This approach works well for tasks with clear rules and predictable outcomes. However, many real-world problems are too complex to be solved with traditional programming alone. Consider the task of identifying a cat in a photograph. It's difficult to write a set of rules that would accurately describe all the possible variations in a cat's appearance, pose, and lighting conditions. This is where machine learning excels. Instead of programming explicit rules, we train a machine learning algorithm on a massive data set of cat images. The algorithm learns to recognize the patterns and features that define a cat, even if those features are not explicitly defined in the code. This data-driven approach allows machine learning to tackle complex problems that would be impossible or impractical to solve with traditional programming methods. Deep learning, the rise of artificial neural networks. Deep learning represents a significant leap forward in the field of machine learning. Inspired by the structure and function of the human brain, deep learning algorithms use artificial neural networks to analyze vast amounts of data and extract complex patterns. These networks consist of interconnected nodes or neurons organized in layers. Each connection between neurons has a weight associated with it, which determines the strength of the connection. As data flows through the network, these weights are adjusted, allowing the network to learn and make predictions. The deep learning refers to the multiple layers in these networks, which enable them to learn hierarchical representations of data. For example, in image recognition, the first layers of a deep learning network might learn to detect simple features like edges and lines. Subsequent layers combine these features to recognize more complex shapes such as circles and squares. Finally, the deepest layers learn to identify specific objects like cars, trees, and faces. This hierarchical learning process allows deep learning algorithms to achieve remarkable accuracy in tasks such as image classification, natural language processing, and speech recognition.